Hi everyone, today we're going to be talking about sequences. Now, a sequence is an ordered list of numbers, and below we have some examples. The 3 dots mean to continue forward in the pattern established. Each number in the sequence is called a term. The expression a sub n is referred to as the general or the nth term of the sequence. Note here that n must be a positive integer. So sequences behave kind of similarly to functions, except the difference is that the domain for a sequence or the input values for a sequence have to be positive integers. So let's look at example 1. It says write the first 4 terms of the sequence a sub n, which is given by that equation. So we want to figure out what is the first term in our sequence, or a sub 1, the second term, the third term, and the fourth term. So we do that by following the equation, and if I want to figure out a sub 1, or the first term, I'm going to plug in and replace n by 1. So that would be 2 times 3 to the power of 0, which is equal to 2 times 1, which is equal to 2. For our second term, I'm going to do the same thing, except I'm going to plug in 2 for my n value. So if we simplify that, we get 2 times 3 to the power of 1, which is 2 times 3, which is 6. I'm going to go ahead and quickly fill in the last 2 terms. Go ahead and pause it maybe and do those on your own. So I've gone ahead and filled out how to find a sub 3 and a sub 4. And hopefully you got those same values. Now this might look a little bit familiar to you in that it kind of has the same characteristics as an exponential function. And again, sequences behave similarly to functions, and so this kind of, you could think of it as an exponential function where the input values are the positive whole numbers. So if I were to write out my sequence, it would be 2, 6, 18, 54, and then we would continue that pattern. So that gives us the first 4 terms of our sequence. In this class, we are going to be dealing with 2 types of sequences. The first type is called an arithmetic sequence. So we have that scenario if there exists a number d called the common difference, such that for any term in the sequence, that term or that value is equal to the previous term in the sequence plus this common difference for values of n greater than 1. Now that looks kind of intimidating, but all that's saying is that we have a common number that we are adding by or subtracting by to get the next value or term in our sequence. A sequence is called a geometric sequence if there exists a number r called the common ratio, such that any term in the sequence is equal to the previous term times our common ratio. So the sequences that we had listed in the beginning, all of them fall into one of these 2 categories. Before we categorize them, why don't we see if we can figure out the next value or term in each sequence? So pause the video and write what you think the next term will be. If you got these 3 numbers, then you are correct. So let's categorize them now. The first sequence is called an arithmetic sequence because the pattern is we are adding 2 each time. So in this scenario, 2 would be our common difference. The next sequence is also arithmetic because the pattern is that we are adding the number 11 to each previous value to get the next value. And then the last example that we have here is a geometric sequence, and that is because the pattern is that we are multiplying by 2 each time. So that's how I got the number 32. So it would be nice if there was a way that we could sum up or add up the first n terms of a geometric sequence. Let's see if we can do that. So the sum of the first n terms of a geometric sequence is, usually we denote it with s sub n, and we use the letter s because of the word sum or summation, and then the subscript n denotes that's the number of terms we are adding up. So the first term in our sequence would be a sub 1, and then the next term would be a sub 2, but another way of writing that is a sub 1 multiplied by our common ratio, and then the next term would be a sub 1 times our common ratio twice, or r squared. That's another way of writing that. And then if I continue this pattern, then we would have a sub 1 times r to the n minus 2 power plus a sub 1 to the r times r to the n minus 1 power. So that's how we would add up the first n terms of a geometric sequence. Now this is going to seem kind of odd, but I'm going to take this equation and I am going to multiply all of the terms by r. So if I did that, the left-hand side of the equation, I would have r times s sub n, and then every term that you see there, I'm going to now multiply it by r. So this first term here, if I were to multiply that by r, then it would be a sub 1 times r, and then this one now, if I multiplied that by r, I would get a sub 1 r squared. And then this would be a sub 1 r to the n minus 1 power. Oops, sorry. That should be n minus 2 plus a sub 1 times r to the n minus 1. So that would be, if I multiplied that term by r, then we would get that one there. And then if I multiplied this last term by r, then we would get a sub 1 times r to the power of n. Okay? Now, why is it that I did that? Well, let's see what happens if I subtract these two equations. So I am going to subtract them, and what's going to end up happening is the left-hand side of that resulting subtraction will be s sub n minus r times s sub n. And then something really nice is going to happen on the right-hand side of the equation. Notice that I've aligned them so that a lot of stuff will cancel out. If it helps you, you can think of there being like a 0 right there and maybe a 0 right here. But if I do a sub 1 times r minus the same a sub 1 times r, then that's going to result in 0. So these terms, if I subtract them, will cancel out. These will cancel out. These will cancel out, and these will cancel out. So what is left on the right-hand side of the equation? Well, we have a sub 1 minus 0, which is just a sub 1. And then here, if I do 0 minus a sub 1 times r to the n power, that's just going to leave me with this. Okay, but I want to come up with a definition to sum the first n terms, or I'm basically trying to figure out that thing here. So what if I factored out s sub n out of this equation? So if I factored out s sub n, then I would be left with 1 minus r. And I'm also going to factor out a sub 1 in the right-hand side of the equation. So that would leave me with 1 minus r to the nth power. And then finally, I want to solve this equation by dividing both sides by 1 minus r. So if I do that, these parts will cancel out, and so I will be left with s sub n equals a sub 1 times 1 minus r to the nth power over 1 minus r. Congratulations, you just helped me to derive the formula for the sum of a geometric sequence. Okay, so my handwriting is not that nice, so let's see the formula again typed out. So the sum of the first n terms of a geometric sequence, where the first term is a sub 1 and the common ratio is r, then the sum is equal to that formula right there, provided that r, or the common ratio, is not equal to 1. Let's utilize this formula now. Example 2 says, find the sums defined below. So part A says, find the sum of the first 20 terms of the geometric sequence with first term 4 and common ratio -3. So let's just write out that sequence. So A sub n would be so the first term in that sequence would be 4, and then the next term would be 4 times -3, so that'd be -12, and then if we multiplied that by -3 again, we would get 36, and then that pattern would continue. So our goal is to try to find the sum of the first 20 terms of this sequence. That's our goal, is to figure that out. So the notation, we would use s sub 20 because we're adding the first 20 terms, and then we can just plug in the values into our formula. So a sub 1, our first term is 4, and then our common ratio is -3, and we will be raising that to the 20th power because we're finding the sum of the first 20 terms, and then the denominator is going to be 1 minus our common ratio. So let's see if we can simplify this a little bit before we throw that into our calculator. Notice that 1 minus -3 is equivalent to 4, so those will divide out, and we'll just be left with 1 minus -3 to the 20th power. So I have gone ahead and thrown that value or expression into our calculator, and this is the number that you will get if you throw that in. So if we continued that sequence and wrote out the first 20 terms, and then we added all those terms together, we would get -3,486,784,400. So that is our value for s sub 20. Okay. Part B says find the sum of the first 9 terms of the geometric sequence defined there. So this one gives us the first 3 terms. So we want to define the first term, which is 1/4, and then we also want to figure out what the common ratio is. So what's the pattern here? Well, it looks like each time we are multiplying by 1/2. So that is our R value. And if we want to find the sum of the first 9 terms, that is s sub 9, and we just plug those values into our formula. So we would do 1/4 times 1 minus the common ratio to the 9th power over 1 minus the common ratio, which is 1/2. So let's see if we can't simplify that a little bit. 1 minus 1/2 is 1/2. And if I'm dividing by 1/2, that is the same thing as multiplying by the reciprocal. So I have that, and then I can simplify that part. If I divide both the numerator and denominator by 2, then I'll be left with 2 there. So I can rewrite that as 1 minus 1/2 to the 9th power divided by 2. So I went ahead and I threw that into my calculator and rounded it to 5 decimal places. All right, see you later.